Finding p-values in hypothesis tests is an area in statistics that causes a lot of confusion, but it does not have to. In this video, I go over a few simple rules that will lead you to the correct answer. One key idea is that the alternate hypothesis gives you a roadmap to finding the correct p-value. When we're testing one-sample problems involving means, the alternate hypothesis will always take on one of three forms. First, if the alternative hypothesis says something like this, mu does not equal 10, this tells you it's a two-tailed test. With two-tailed tests, you always calculate p-values using the combined areas in the two tails. If the alternate hypothesis says something like this, mu is greater than 10, this tells you it's a one-tailed test. With one-tailed tests, you always calculate the p-value using the area in the direction of the rejection region. So when the alternate says mu is greater than 10, you reject in the direction of the upper tail. If the alternative hypothesis says something like this, mu is less than 10, this tells you it's a one-tailed test rejecting in the lower tail, so you reject in the direction of the lower tail. If sigma is known, find the p-value using the normal distribution, but if sigma is unknown, find p-values from the t-distribution with n-1 degrees of freedom. We will use this concept for the rest of the class, not just this lesson, so it's important to understand how to find p-values. In this example, we have a sample of 9 measurements from a normally distributed population. The sample mean is 2.57, with a sample standard deviation of 0.3. The alternate hypothesis is that mu does not equal 3. This is a two-tailed test, so we find the p-value in both tails using the t-distribution with 8 degrees of freedom. Here I use R as a smart calculator for the solution. T equals the sample mean of 2.57 minus the hypothesized population mean of 3, divided by the sample standard deviation, 0.3, over the square root of the sample size. The calculated value of the test statistic is minus 4.3, and I stored this value in an object named t. The pt function, with q equaling minus 4.3 with 8 degrees of freedom, gave me the lower tail area by default. I multiplied this area by 2 in order to find the two-tailed area of 0.0026. This is a low p-value, and you would reject the null hypothesis. In the next example, the alternate hypothesis is mu is greater than 8. The sample size is 25, the sample mean is 7.99, and the sample standard deviation is 0.16. This is a one-tailed test, rejecting the upper tail. Sigma is unknown, so find the p-value in the direction of the upper tail using a t-distribution with 24 degrees of freedom. The calculated value of the test statistic is minus 0.3125, and the upper tail p-value is 0.621. This is a high p-value, so you do not reject the null hypothesis. In this example, a sample of 16 customer transactions had a sample mean of 7.3 minutes with a sample standard deviation of 2 minutes. The null hypothesis is that mu is equal to or greater than 7.5 minutes. The null is equal to or greater than, so the alternate is that mu is less than 7.5 minutes. This rejects in the lower tail, so find the p-value in the direction of the lower tail. The calculated value of the test statistic is minus 0.4, and the lower tail p-value is 0.347, so do not reject the null hypothesis. Finding p-values confuses many people, but it does not have to. Just remember, you always reject in the direction of the alternate hypothesis. If the alternate rejects in the upper tail, find the p-value in the direction of the upper tail. If the alternate rejects in the lower tail, find the p-value in the lower tail. And if the alternate is two-tailed, find the p-value in the combined upper and lower tails. Thanks for watching, and please let me know if you have any questions.